All right, we are moving ahead to Lesson 5 of Unit 7. And Lesson 5 is an intro to what we call the normal distribution, a very popular topic within statistics, and this is a statistics unit. So a normal distribution, another word for a normal distribution is what we call a bell curve, and you can see based on the example here why they call it a bell curve, okay? One of the characteristics of a normal distribution is that it is bell-shaped. Okay, you can see that it is symmetric. Okay, you can see that it is symmetric. It is what we call unimodal, meaning that there is one high point. So there's one high point up here. We already talked about bell-shaped. The x-axis down here. The x-axis down here is a horizontal asymptote. So the graph never touches the x-axis, but it gets infinitely close to it. The area between the x-axis and the curve is 1 or 100%. In this case, what they're talking about is the blue shaded area. If I were to calculate the area of the blue shaded area, it would be 1 or 100%. And it is determined entirely by the mean, the average, and the standard deviation, how spread out shouldn't be the date, it should be how the data is from the mean. So I'm going to fix that right now so you don't get confused. Okay, so the standard deviation is how spread out the data is from the mean. So the more spread out it is, the higher the standard deviation is. The less spread out it is, the lower the standard deviation is. So it's determined entirely by the mean and the standard deviation. Okay, so let's take a look at the examples. These curves represent different normal distributions with different means and standard deviations. What do you notice? So the first thing I'm going to look at is where the means are. So notice this one has a mean of 10, and if I look at the high point or the center, it's at 10. This one has a mean of 12. Notice its high point or center is at 12. This one also has a mean of 10. Notice the high point is at 10. Do you think that's a coincidence? Definitely not. So that's the first thing I notice, and I'm going to write that down. So the mean is where the high point, of the bell or the center is. So the center is where the mean is. So that means 50%, and being that it is symmetrical, so I'm going to write that down, because it is symmetrical, 50% of the data, and let's throw date again, is less than the mean, and 50% of the data is greater than the mean. And why is that the case? Because it's symmetrical. Okay. The next thing I want to look at is what happens if we have different means. So different means, but same standard deviation. Okay, so we talked about this in the lesson notes, how a normal distribution is determined by its mean and its standard deviation. So what happens if we have different means but the same standard deviation? So that would be like this example, these two right here. These two, this one has a mean of 10, this one has a mean of 12, but they both have a standard deviation of 1. So notice they both look exactly the same. The only difference is this one, the center is at 10, and this one, the center is at 12. So they're both the same shape. They both look exactly the same. One is just shifted over from the other. Okay, the one with a mean of 12 is shifted to the right 2 units. We have another example with these two right here. Okay, notice they both have standard deviations of 2, but this one has a mean of 10, this one has a mean of 8. And again, we'll look at the centers. Here the center is at 10, this one is shifted over to the left 2 units, but other than that, they look exactly the same. So that is the main difference here. When I have different means but the same standard deviations, the graph will look exactly the same. The graphs will look exactly the same. Okay, one of them will be shifted. Shifted left or right. Okay, so whether it was these two or these two, okay, both pairs looked exactly the same. One was just shifted left or right of the other. Okay, so that is number 2. That is the second thing I want to look at. The last thing I want to look at is what if we have the same mean but different standard deviations. Okay, so that would be something like this. Okay, these both have means of 10. Notice the center, the high points are both at 10, but one has a standard deviation of 1 and the other has a standard deviation of 2. So notice the one that has the lesser standard deviation, the bell part of the curve is taller and narrower. Okay, here, the one with the larger standard deviation, it's more spread out. Okay, let's take a look at another example. Okay, so we did that one. Here we have another example right here. Okay, both of these have standard deviations of 10. Or excuse me, they both have means of 10. They both have means of 10, but this one has a standard deviation of 2. This one has a standard deviation of 0.5. Okay, notice the one with the lesser standard deviation, the bell part of the bell curve is taller and narrower, and the one with the larger standard deviation over here is lower and spread out more. Okay, so that is the pattern here. So so how will I describe this? The bell part of the one with the lesser standard deviation will be taller and narrower. The one with the larger standard deviation will be shorter and spread out more. Okay, and that is it for our examples. We wanted to look at these different characteristics of a normal distribution, basically kind of an intro lesson to a normal distribution. We will talk more about this, about a normal, distribution in our next lesson.